logarithm. Now, for us to understand or to work with logarithms, we need to know their properties. So the first property is that the logarithm of the base is 1. So log a of a is 1. Now the a is never equal to 1 or 0. So meaning that if you have log 10 10, you are going to get 1. But if you have log 1 1, when you determine the value, is still you doing it without getting an answer. And the second property is that logarithm of 1 is 0. Logarithm of 1 is 0 to any base. Again, the a cannot be equal to 1. Now, if you have logarithm of a number that are multiplying, two numbers that are multiplying, can be 2 or more. Log m times n to base a is equal to log m to base a plus log n to base a. Then when they are dividing, this time it is subtraction. Then this one, if you have the number being an exponent or the number is in the index form, then the exponent comes to multiply the whole logarithm. So log of m to the power n to base a will give us n times log of m to the base a. So now let's look at how we can use the property to solve some examples. This is Wasi May June 2012. Which of these statements about y equal 8 root m is correct? Now looking at the options, we have logarithm in the options. So what we do is that we take logarithm of both sides to base 10. Now I forgot to tell you that if we have log to base 10 of any number, we can simply write it as log m. So if the base is not written, you have to know that it's in base 10. If the base is not written, then it is in base 10. So now, if we take logarithm of both sides to base 10, we are going to get log y. Log y is equal to log 8 root m. So now we apply the property. We apply this property to the right hand side. So we are going to get log y is equal to log 8 plus log root m. Now the next thing we do is to write this as exponents. We know that log y will be equal to, now this is the same as log 2 to the power 3. That is how we can write 8 as an index number. Then plus log m to the power 1 over 2. So we now use the property which says that log to base a of m to the power n is equal to n log a of m. So this will give us log y to be equal to 3 log 2 plus 1 over 2 log m. So the result is D. Now we have this. So what we can do now is, we know 2 is common to both sides, so we divide through by 2 to obtain. So divide through by 2. So divided by 2 by 2. So we are going to get log of 3 whole number 3 over 8 to base x is equal to 3. Now we can write this as improper fraction to obtain log of 3 times 8 to give us 24 plus 3, that will give us 27. Log of 27 over 8 to base x. is equal to 3. We have several ways that we can proceed from here, but the simplest one is to write this as an initial equation. So we can write this as 27 over 8 is equal to x to the power 3. So you can review that. So that is the relation between logarithm and exponential equations. Now over here we can rewrite this, or we can take the cube root of this, or write this as a number raised to the power 3. So we have 3 over 2 all to the power 3. That will give us 27 over 8 is equal to x to the power 3. So now, because the exponents are the same, we can write that the bases are also the same. Therefore x is equal to 3 over 2. You could also decide to take the cube root of both sides. So the result is A. Now we have another one over here. We want to simplify log of root 27 over log of root 81. And we can write this as an index number. So this will give us log of 27 to the power 1 over 3, 1 over 2 rather, all over log of 81 to the power 1 over 2. Now note that this is in base 10 because the base is not written, so it is in base 10. Now this will be equal to 1 over 2 log 27 all over 1 over 2 log 81. So this can cancel this now, and we are left with, the 27 can be rewritten as 3 raised to the power 3. Then the 81 can be rewritten as 3 raised to the power 4. So because this is taking care of this, now we can simplify this further using the law again. So this time it comes to multiply. Remember that law, that log of m to the power n to base a is equal to n log m. So the a here is 10, which is not written. So don't let that confuse you. The a here is 10, which is not written over here. So now we can apply this law to obtain 3 log 3 over 4 log 3. So the log 3's will now cancel, and we are left with 3 over 4. So the answer is now D, option D. So we have this: if log 2 equal x, log 3 equal y, and log 7 equal z. Find in terms of x, y, and z the value of log 28 over 3. We know that we can write log 28 over 3 using that law. So we are going to get log 28 or 28 minus log 23, log 3 rather. But look at something. 28, we don't have 28 over here, but we have 3 here. So we have to express 28 as a product of 7 and 2. But that will be equal to log of 4 times 7. So this will be equal to log of 4 times 7, which will give us 28 minus log 3. Now we apply the product rule again over here. So we are going to get log of 4 plus log of 7 minus log of 3. Now This will give us log, the 4 can be rewritten as 2 to the power 2 plus log 7 then minus log 3. So we apply the exponent law again, which tells us that the exponent will multiply the whole logarithm, plus we have log 7 then minus log 3. So now we can do the substitution now. So whenever we see log 2, we put x, so this will give us 2x plus log 7 is y, log 7 is z, then minus y. So the result is 2x plus z plus minus y, that is